we're going to talk about what we call molecular geometry. Okay. Now, for molecular geometry, guys, what we need is we need to tell what is the shape of the molecule. Remember, guys, when we talked about that CH4 molecule, you don't have to draw this right now. But you see how I randomly just showed you that CH4 looks like this?
Mm-hmm.
Um, but actually, CH4 in 3 dimensions in the real life looks like this.
What the heck?
Okay. So, what is this trying to show? You don't have to draw this on the exam. Guys, I'm getting some background noise. Let me see where is that coming from. Matt, I'm going to try to mute you. Maybe it's coming from your side, okay? Okay. So we have CH4 and we have 2 hydrogens just like that. So if this was face to face, this is what I mean, guys. If you guys can all see this wall?
Yes.
Yes. Okay. You see how this is one plane, right?
Mm.
Uh, all the molecules, of course, are in 3 dimensions. They are not plane like this. Okay. Instead, you have atoms coming outside of this plane or going into the board. So what I'm saying is I'm going to have 2 hydrogens on the carbon, which are 1 hydrogen which is going inside the wall and 1 hydrogen which is coming outside of the wall. Those are these 2 hydrogens that I'm trying to show you. Okay, so you have a molecule which is like a tripod stand. You know the tripod stand where you put the camera on the top? So this is
Mhm.
like your camera on the top. This is the joint of the 3 legs of a tripod, and then these are the 3 legs.
Oh, okay.
You see how 3 legs are like that on a tripod stand, and then
Yeah.
on the very top you have the camera. So that's what this thing is. That's how actually CH4 looks like. It does not look like this structure that we normally draw for Lewis structure, okay? Now, again, I said you're not responsible for drawing them like this. You just need to know that they actually are 3 dimensional. And this shape right here is called tetrahedral. Uh, all of these, you're going to see them on this chart that I was showing you earlier. Is see tetrahedral here? You see this is tetrahedral? Okay, so let's talk about this now. I'll go back to the example for CO2. You all remember this structure that we just draw for CO2? So the exam questions will be like this. I'll give you, let's say, the Lewis structure, or I'll just give you randomly a molecule CO2, and then you'll first draw the Lewis structure in your rough notebook, and then I'm going to ask you what is the molecular geometry for that molecule. And you will be picking from this table if that molecule is going to be linear or trigonal planar or bent or tetrahedral or trigonal pyramidal or bent. Okay. We'll learn how to figure that out, but this is where you're going to find that information. So for CO2, guys, do you guys actually have this? Let me see if I can bring. Okay. Okay. Now, for CO2, guys, I'm going to ask you a couple of questions, okay? Tell me, so when you're reading this table, your focus should always be on the central atom. So all this information that is being asked, electron groups, bonding groups, and lone pair. This is where our focus is right now, okay? And I'm going to ask you some questions here. tell me that your central atom carbon has how many electron groups? By electron groups, guys, another word for group is neighbor. Just to make it sound more simpler, I'm saying that if I ask you, this carbon has total how many neighbors, what are you going to say?
2.
You're going to say it has two neighbors. One is this oxygen and one is this oxygen, right? So
Right.
it has two neighbors in total, and you're good. That makes sense to me. So yes, it has two total neighbors. So out of those two total neighbors, how many of those two neighbors are bonded neighbors, and how many of the total neighbors are lone pairs? So let me give you one example here. Let's say I have the central atom, which looks like this. Can you tell me the central atom has how many total neighbors?
2.
Guys, remember that lone pair counts as one neighbor, okay?
No,
So
3.
don't ignore that. So guys, central atom is A. A has how many total neighbors?
3.
How many of those are bonded neighbors?
2.
2. See, out of these three neighbors, 2 are bonded. And how many lone pairs?
1.
1. Now guys, when I'm asking you lone pairs, if there are lone pairs on this X, we don't care.
Okay.
We only care about the central atom. That central atom has what? So all this information that you have is for the central atom. Does that part make sense, guys?
Yes.
Okay. So if I go back to the CO2 example, look at the CO2 and tell me this carbon has how many neighbors total?
2.
2.
Neighbors. One neighbor is this, one neighbor is this. It does not have any lone pair, so only two neighbors. Out of those two neighbors, are both of them bonded neighbors?
Yes.
Yes.
So total neighbors is 2. Bonded neighbors are 2. How many lone pairs?
0.
0. If you guys are thinking, no, I see 3 lone pairs here and 3 lone pairs here, you don't have to look at those lone pairs. You're going to look at carbon. This information is for the central atom and not for outer atoms. So carbon has no lone pair, so I'm putting a 0. Does that make sense, guys?
Yes.
Now look back here and tell me if you see this one here, then which table does this match with? Like all the numbers match with what? So you see this number 220? You see 220 right here? There's no other 220, right? There's 220, there's 330, there's 321, there's 440, 431, 422. You see we have 220 for CO2. So 220 for CO2 means what is the shape going to be?
Linear.
Linear.
Going to be linear. And electron geometry is not what you care about. You care about molecular geometry.
Mm-hmm.
So what I'm going to say is that my answer is that this molecule is linear. Okay.
Okay.
Sorry, what did you mean by bonded groups?
But bonded group, we mean that,
Yeah.
let me go back to the simple example, the general example. Okay. Now, if I ask you again, how many total neighbors we have, that's the electron groups. How many electron groups are total neighbors?
2.
Nope, 3. See, this is one neighbor, X. This is another neighbor, X. And then this lone pair is also a neighbor. It is not a bonded neighbor, but it's a lone pair neighbor. But it's a neighbor.
Okay.
So
So
there can only be
that's
two
why-
lone pairs.
What's that?
There can only be 2 lone pairs in the center because
Yeah, there can be 2 lone pairs in the center, yes. Like in this example, we're going to see this, like 4 to 2 example. This is basically water.
Mhm.
Okay, we're going to see that. So total is actually this number plus this number should match this number. Okay. All right. Now let's do some more examples here. Let's go to water. You guys remember the Lewis structure for water that we drew?
Yes.
Can you answer the same questions again? How many electron groups do we have? How many bonded groups do we have? And how many lone pairs do we have? So guys, how many electron groups? Again, if the group word does not click, simply replace it with neighbors.
1, 2, 3, 4.
So oxygen has how many neighbors? This is one neighbor. This hydrogen is another neighbor. And then this lone pair is one neighbor. This lone pair on the top is the fourth neighbor.
4, yeah.
So how many total electron groups are total neighbor? 4.
4.
How many of those 4 are bonded?
2,
2.
2. And how many of those 4 are lone pairs?
2.
2.
We see these two numbers add up to the number on the top.
Yes.
Mm-hmm.
Confused on the electron groups. How is it 4 again?
So electron group is basically electron groups are 2 types. The bonded groups and the lone pairs. These are 2 types of electron groups. Okay, so this oxygen has this hydrogen, that's one neighbor. This is one neighbor. This lone pair is one neighbor, and this lone pair is another neighbor. So when we say electron groups, we're basically counting total neighbors. Oxygen has 1, 2, 3, 4 neighbors. That's why we are saying that electron groups are 4.
Okay, got it.